Hello. So I've been preparing for this episode and I've discovered something that I'd overlooked previously, which is pretty important. If you remember in mouse input video, I've alluded to the fact that the mouse input is not perfect, and what I meant by that is the following. Well, I don't have it here anymore, so let me first grab from mouse input video. I'll grab the test code. Where is the test code? Here it is. So we're gonna output the position of our cursor, and let's see. So as you can see, our window is 1280 by 720, but as I go in this corner, as you can see, it's 1244 on the x-axis and 661 on the y-axis, and that happens because our window is 1280 by 720, including the this title bar and these buttons. But actually, when we set the canvas size or the window size, what we mean by window size is the canvas size. So if we want our game to have resolution 1280 by 720, we want the canvas to be 1280 by 720, and but we get a smaller value because of the title bar and whatnot. To adjust the size of the window, we have to go to the window initialization code, and in here, so we've registered the class, and before creating the window, we will adjust the window size. And we'll do that by first off creating a variable called, let's call it window style, and it's gonna have ws not title bar, I guess, maximize box, definitely that, ws sys menu, and ws it's not title, what is it then? Caption, yeah. So this is the style of our window. This is the style that our window has. We've just kind of put this style into this variable, and then we're gonna have rect window rect, and so window rect has four properties: bottom, left, right, and top. But we're not gonna need the left, so we'll set it to 0. We'll set to 0 the top, and since we're setting those to 0, the right property can just be window width, and the height is gonna be the bottom is just gonna be window height, bottom, and adjust window rect, and it takes rect, our style, and boolean menu, which has something to do with the window menus, you know, like those menus like file, edit, view, but we don't have those because we're making a game framework. So pointer to the window rect, give it the window style, and false for this flag. And what this does is it takes our window rect we provided, and based on the window style, it adjusts the window rect. And so in here we don't need left and top because we're using use default for the window position, but window height is gonna be taken from window rect.right, and window rect.bottom is our adjusted size, and that's it. So after registering the class, we've defined window style and window rect. We've adjusted the window rect based on our window style, and then we use that in here for our window size and window position in create window X. Now let's see. So it still isn't working properly, probably because, yeah, I overlooked. So we actually have to do this minus and top. Yeah, because it's a rectangle not with X, Y, and width and height, but left, top, right, and bottom. So to get the width, we have to subtract left from the right, and to get the height, we have to subtract bottom from the top. So yeah, now as you can see, I'm very close to the bottom right corner of the window, and the position is 1276 and 717. So very close to the actual window size, and you'll probably not be able to get, yeah, I'm right on the edge, 1279 and 719. Okay, so this is taken care of, and the way that I've discovered it was when I was preparing for this video for the 2D graphics kind of render functions, and the graphics were not rendering properly. It was like it was squished or just a bit broken. So it was kinda right, but a bit broken. So yeah, that means that adjusting the window rectangle is very important. And you really should take care of that, because if you don't, then the graphics will not be rendered properly as well. So now, so far we have three public functions for the renderer: set clear color, set pixel, and fill rectangle. So let's actually add a couple more things. So first off, we're gonna have draw rectangle, and this will render the rectangle outline. So only the outline without actually filling the rectangle. And then we're gonna have draw line, which we specify 2 points, and it draws the line connecting those 2 points. Then draw circle will render the outline of a particular circle, and fill circle will fill a circle. So let's actually define point, struct point int x, y. But also we're gonna have we're gonna also overload those functions. You know what? Let's actually do no point. We could always add that later. So let's just do int origin x, int origin y, and same here. And we're gonna implement those functions. So where is our fill rectangle? Now let's implement render draw rectangle. Okay, so in here, just like in fill rectangle, we for convenience we take the buffer like that because we use it in a bunch of places. Then we calculate minimum x and y and maximum x and y, and then we clip it, just like we did in fill rectangle. Now so this part stays the same. What's different about this is that we're not gonna do this. We're not gonna use raw pointers. We're actually gonna use the set pixel function just for convenience. And we have, this is just for testing, remove that. And we have two loops, two for loops in here. We go from minimum x to maximum x, and we set the pixel so x stays. What we do in this first loop is we draw kind of the top and the bottom lines that make up a rectangle. On each iteration we move the x, right? But we draw on minimum y and maximum y, so top and the bottom. And the second for loop, what it does is it basically draws the left and the right lines. And yeah, so minimum x and maximum x. This is a simple algorithm. Now let's test it. So let's do it after set pixel. I'm gonna do use, actually let's take this one and draw rectangle. We're gonna give it 800 and 450 and 120, 100, and we're gonna make it let's make it blue. Okay, and let's test this out. So let's make it blue. Okay, as you can see, we are drawing this neat little rectangle. Now let's implement the rest of those functions. Now the draw line function will need we'll actually need two kind of helper functions that we're gonna define as private. Okay, it's gonna be plot line low and plot line high. And so now we're gonna implement those three functions. Now, at first, I wanna just point out that I don't actually know how these work. Like, I don't understand those algorithms. And well, first off, I'm not that kind of smart to be able to understand it very well, but also in my experience, even if you understand the math of the algorithm, you still it doesn't mean you can actually implement the algorithm. It's, for example, like in bubble sort, right? You have to move right? You have to swap the elements of an array. And you can understand the math, you can understand the algorithm, but how the hell do you swap, right? Like, it's those minute details that make up all the difficulty in my experience of actually implementing an algorithm. So, but with swapping, of course, it's easy. You just make a temporary variable. So how did I implement the draw line function if I don't really understand the algorithm? The answer is the internet. So we're using Brazenham's line algorithm, and what I did is I scrolled to the implementation, and here in all cases, as you can see, there is plot line low, which is this, plot line high, which is this, and then plot line that uses those plot line low and plot line high, which is this one. So what I did is I copied the code, and it's like pseudocode, so I just converted it to C++ code. Here it is. So plot line low, it looks exactly as this. So dx, dy, yi, as you can see, if d less than y, d2 multiplied by dy, this is all right here. Plot is our set pixel. So yeah, plotline low and plotline high. I don't really know how these work. I have a general idea, but you know, if you're interested in the math behind this, just check out this article on Wiki, Brazenham's line algorithm. And also, if you wanna just copy this code, you know, under each of the videos that I post, I leave a link to the GitHub repo where you can get all this code. And now here it is. Also, I'm using those like get absolute value, and apparently this compiler that I'm using, so Visual Studio compiler, has this function built in, or maybe it's from the windows.h. So if you're on Visual Studio, this should work fine for you. If not, this is just getting the absolute value. You can implement this function pretty easily. So void int abs int x, and what you do is not void int, just int. If x is less than 0, then you return minus x, and else you return x. This is very simple, right? This is what this function essentially is. Okay, now let's test the draw line. Okay, so this should have, we should have a nice green line right here. Perfect. Okay, now let's move on to the draw circle and fill circle. Now, once again, don't really understand the math behind it, but I just literally just googled you know, an algorithm for drawing circles, and so came upon this Stack Overflow post, fast algorithm for drawing filled circles. I'm using Brazenham's circle algorithm, blah blah blah. This answer here, just use brute force, and yeah, I just copied this one. Also, there seems to be a problem where the circles that are drawn with the brute force algorithm are thinner than the equivalent in midpoint algorithm, which is just another algorithm for drawing circles. I think it's this one, which is it has two names, and appear to be more correct shape. Any way to fix that? And here the same person provides the answer that seems to work for them, and then another person, Marcin, says that yeah, but this one also works. So I've just copied this line and I changed it in here. So here it is, fill circle. So yeah, it's that algorithm, just with this line swapped for this line, just like that. And we're also using set pixel in here, and the draw circle also here. They provide also to get just the circle, meaning the ring or the outline. You can do this if blah 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 blah. So I just took this, literally just did that, then draw circle, and then I swapped this if with this if, just like that, and that's it. So let's test this out. So we're gonna fill a circle with radius 50 and the center 500, the origin 500 and 500, and we're gonna draw a circle. So with radius 80 at position 100 and 100, and the filled circle is gonna be completely white, and the just a circle is gonna be red. And as you can see, at position 100 100 we get a nice circle, and then with the radius 80 and with the radius 50, this nice circle, white one. And as you can see, it looks pretty good. So the algorithm is, you know, very pretty nice. And yeah, so that's it for this video. Yeah, bye.